Okay, so if you missed class today we talked about one-to-one functions. For something to be a one-to-one function, it has to be a function first. Remember from our last unit that a function is where x's do not repeat and it passes the vertical line test. So for something to be a one-to-one function, a function is 1 to 1 if any two different inputs in the domain correspond to two different outputs in the range. So all that really means is that your x's and your y's both don't repeat. So nothing repeats. When we had a function, it passed the vertical line test. To be a one-to-one function, it must also pass what we're going to call the horizontal line test. So we're going to fill in the blanks. If every horizontal line, I'm going to abbreviate here, if every horizontal line intersects the graph of a function f in at most one point, then the function is said to be 1 to 1. Alright, so what we're going to do now is we're going to practice what we just said. So over here, it says 1 to 1, not 1 to 1. So we're going to decide which way each one of these examples should go. So example 1, we have negative 2, 6, negative 1, 3, 0, 2, 1, 5, 2, 8. Nothing repeated, so it is a one-to-one function. Second example, negative 1, 6, 0, 3, 1, 6, 2, 5, 3, 8. You'll notice I had two y values repeat. So it is a function, but it is not one-to-one because my y is repeated. These next two examples are both called mappings. And we have to review how to read this. This says negative 2, 5, 4, 12, 8, 12, 13, 18. I think I said 12 twice, so that means my y is repeated, so it's not one-to-one. The next mapping, negative 2, 5, 4, 0, 8, 12, and 13, 18. Nothing repeated. This is a one-to-one function. These last two are my graphs. They've already passed the vertical line test. Now we're going to see if they pass the horizontal line test. So if I were to draw a horizontal line anywhere across this graph, it would only touch one time. It's 1 to 1. If I were to draw a horizontal line across this graph, it actually touches twice, so it is not 1 to 1. All right. So after discussing one-to-one functions, we reviewed a little Algebra 2, and we reviewed what it was to be an inverse. To find the inverse of any set of points, all we have to do is go flip the x and the y. So we're going to flip x and y. So on this data right here, we have negative 3, negative 2, negative 1, 4, 0, 3, 2, negative 1, and 4, 0. So if I want to write the inverse, and here's my notation for inverse, I take everything that was a y, and it becomes my new x, also known as the domain, and everything that was an x will now become a y. So this is my new range. This is the inverse of f of x. If you're going to graph an inverse, it's going to work the same way. We're going to take whatever ordered pairs they give me, and I'm going to flip them. So I'm going to go flip this point over here. I'm going to flip this point right here. And when I go graph the actual picture, it needs to not only have the ordered pairs the opposite, but it has to be a mirror image across the line y equals x. So it's going to look something like this. Okay, I didn't do the best job. I did a pretty good job there. So you'll notice if I were to fold this over the line y equals x, they should line up on top of each other. So when they ask you to graph an inverse, you're going to flip the x and y, and it should be a mirror image over the line y equals x. To find the inverse of an equation, we're going to follow the same steps. We're going to flip the x and y and solve. So my original equation was f of x equals 2x plus 3. The first thing we want to do is go rewrite f of x as y equals 2x plus 3. Then we're going to switch the x's and y's. So x equals 2y plus 3. and we're going to solve for y. So if I ask you to solve this for y, we need to get rid of the 3. So we're going to minus 3 from both sides. We get x minus 3 equals 2y. And then we're going to divide everything by 2. So my inverse function equals x minus 3 over 2. Or we could also write it as x over 2 minus 3/2. These are equivalent equations, and we can write it either way. And the last thing we covered while you were out today is we covered how to prove two equations are inverses. Two equations are inverses if and only if the composite of each other are both x. So we're going to do two composites. The first composite we're going to do is we're going to take our second function and we're going to plug it into our first function. That's the first thing I'm going to do. So 2 parentheses 1/2 x minus 3/2 plus 3. So I'm going to go distribute. 2 times 1/2 is 1x. 2 times negative 3/2 is negative 3 plus 3. These 3's will cancel, and I'm left with an x. Now I'm going to go do it the other way. I'm going to take this first function, and I'm going to plug it in over here. So I'm going to take this function and plug it in over here. So 1/2 parentheses 2x plus 3 minus 3/2. 1/2 times 2 is x. 1/2 times 3 is 3/2 minus 3/2. Those cancel, and all I have left is x. So yes, these are inverses. So today in class, we mostly reviewed something you'd already covered in your Algebra 2 class, and then I passed out the homework. On the homework, I made sure to let everybody know which problems that we omitted. So you need to go through your worksheet and put an X through these problems: 28, 30, 34, through 36, 42, through 46, 51, 52, and 55. Okay. The next thing I did in class is I went through a couple of examples just to make sure everybody understood the directions. So on 13 through 16, all you have to do is determine yes or no if it's 1-to-1. So on 13, we have 2, 6, negative 3, 6, 4, 0, and 1, 10. As you can see, I had two y's repeat. So no, it's not 1-to-1. On 17 through 22, we're still trying to decide yes or no, and we're using the horizontal line test. So on 18, if I were to draw a horizontal line anywhere across this graph, it would only touch one time. So this is yes, it's 1-to-1. On number 20, if I were to draw a horizontal line, it touches twice. So this one is no, it's not 1-to-1. On 27 and 29, they want you to find the inverse and then state the domain and range. So remember, the inverse means I just flip them. So my inverse is 5, negative 3, 9, negative 2, 2, negative 1, 11, 0, and negative 5, 1. The domain of my new inverse function is 5, 9, 2, 11, and negative 5. Now we should have written these from smallest to biggest, but I'm just trying to save time. My range is going to be my new y values of negative 3, negative 2, negative 1, 0, and 1. On 31 through 33, they want me to graph the inverse. So I'm going to go flip my points. 1, 2, I'm going to graph 2, 1. Where it says 0, 1, I'm going to graph 1, 0. Where it says negative 1, 0, I'm going to graph 0, negative 1. And negative 2 flipped is just negative 2, negative 2. Now before you go connect your points, remember that it has to be a mirror image across this line. So if I were to fold my paper on this line, y equals x, these two sides should line up on top of each other. On 37, on this section, they want you to prove that they're inverses of each other. So before I start this problem, I'm going to go ahead and distribute the 1/3. I have 1/3 x minus 4/3. And just like we did in our examples, I'm going to plug g into f and f into g, and they're both supposed to give me x. So I'm going to start off with 3 parentheses. I'm going to go plug in g, 1/3 x minus 4/3 plus 4. So I'm going to go distribute, and I get 1x minus 4 plus 4 equals x. Now I'm going to do the other side. I'm going to take this function right here, and I'm going to plug f in for x. So 1/3 parentheses 3x plus 4 minus 4/3. So we get x plus 4/3 minus 4/3, and we get x. We both get x, so yes, they are inverses. The last problem I did with all the classes today was number 47. For 47 through 58, it says that the graph of the function is 1 to 1. They want you to graph this function, find the inverse, and graph the inverse. So I have to do 3 things. I have to graph this one. I have to find the inverse function. And then I have to graph the inverse. Okay, so the first thing I'm going to do is I'm going to get me a little t-chart going here. And I'm going to graph the original function. So if I plug in -1, I get -3. 0, I get 0. 1, I get 3. I'm going to come over here to my graph, and I'm going to draw in a little xy. And I'm going to go graph these points. So I'm going to go graph the point -1, -3, 0, 0, and 1, 3. And I'm going to go draw as straight a line as I can and label it f of x. So that's your original function. Now I'm going to go find the inverse. To find the inverse, the first thing we have to do is we have to go switch the x and y. And now I'm going to go solve for y. So there's nothing to add or subtract, so all I have left to do is divide. So the inverse equals x over 3, or 1/3 x. We can write it either way, x over 3 or 1/3 x. And then I'm going to go graph it. Instead of trying to plug in, I'm just going to take my original points and flip them. So now I'm going to go graph -3, -1, 0, 0, and 3, 1. When I graph this one, I'm going to make it a dashed line or use a different color, so that I know the difference between the original and the inverse. It also asks you in the problem to state the domain and range of both functions. These are both linear functions. We never did any division or any square roots. So the domain and range for both of these are all real numbers. So I'm going to write right here, domain, all real numbers, range, all real numbers, and I'm going to write for both. Okay, good luck on your homework. Ask me questions on Friday.